Hey guys, welcome to this session. Our topic is periodic classification. So today we are going to discuss about the periodic classification. So let's start with the introduction to periodic classification. Periodic classification of elements. This is the method by which elements are grouped on the basis of their characteristics. It's simply the arrangement of all elements in accordance with their increasing atomic number. We've already seen what is atomic number. We've seen the mass number. So basically, this periodic classification is the arrangement of all the elements in the table in accordance with the increasing atomic number. This means starting from the small one to the large one, and their recurring chemical properties, simply known as a periodic table. So this arrangement is what we call the periodic table. Now, this is just an illustration of the periodic table of the first 20 elements, starting from hydrogen to calcium. The first one is hydrogen, second one is helium, third one is lithium, fourth one is beryllium, fifth one is boron, sixth one is carbon, seventh one is nitrogen, eighth one is oxygen, ninth one is fluorine, 10th one is neon, 11th one is sodium, 12th one is magnesium, 13th one is aluminium, 14th one is silicon, 15th is phosphorus, 16th is sulfur, 17th is chlorine, 18th is argon, 19th is potassium, and the last one, the 20th one is calcium. Now, let's discuss about this, the modern periodic table. Before this, there have been some other periodic tables invented. Now, let's discuss about this, the modern periodic table. The long form of the periodic table is the commonly used form of the periodic table. Now, the elements in the table are arranged based on their atomic weights or atomic number, starting from hydrogen, helium, lithium, beryllium, and so on. The elements appear in the vertical columns and the horizontal rows. The vertical columns in the table are called as groups, numbered 1, 2, 3, 4, 5, 6, 7, and O, which is also known as group 8. Group 1 contains the elements lithium, sodium, rubidium, pycelium, and francium. These others are from the others. Group 2 consists of elements starting from the beryllium down to radium. Some of the groups have special names. Group 1 is often called as alkyl metals. Group 2 are called the alkaline earth metals. Group 7 are called as the halogens, and the group O are the noble gases. The horizontal rows are called the periods. The periods starting from the first one consists of hydrogen and helium. Period 2 consists of lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Moving on to down rows, all these are known as periods. The transition metals or elements form a separate block in the middle of the periodic table between group 2 and group 3. The atoms of these elements have more complicated electronic arrangements. We'll see about this, the electronic arrangements, also known as electronic configuration. Note that the group contains many common metals such as iron, nickel, copper, and zinc. Now, one of the interesting properties of these elements is that they form colored compounds. Let's see the main features of the modern periodic table. The first one, that the elements in the table are placed in order of their atomic numbers instead of their atomic masses. The second one, that there are a total of 18 groups and 7 periods. There are 5 blocks of similar elements in the periodic table, as shown in the figure above, which we've seen with the first 20 elements. The first one, that the normal or the non-transition elements groups groups 1 to 7 have their outermost shells incomplete, meaning that they can allow additional electrons to enter into their outermost orbital or valence shell, that each of their inner shells are complete. The fifth feature, that the transition metals have the outermost as well as their penultimate, the second last shells that are incomplete. Elements of group O, known as noble gases, have their shells complete. These elements show little reactivity. That's why they are once called inert gases, because they are very unreactive, or rare gases because they are rarely found. The seventh feature that gaps left by Mendeleev, this was a scientist who discovered one of the periodic table for the undiscovered elements now occupied by the transition elements, and the noble gases have been filled by their respective elements following their discovery. Now also man-made elements have also found a place in the periodic table. The eighth feature is that the metals have been clearly separated from the non-metals. Metalloids or semi-metals have also been included. Metalloids are elements whose properties are intermediate between metals and non-metals. They include boron, silicon, germanium, arsenic, antimony, and tellurium. In some publications, the germanium and the antimony are usually classified as poor metals, and the rest as non-metals. So that's all for this video. Basically, we've discussed about the modern periodic table. We've seen the various features that are found in this modern periodic table. We've seen the illustration of this modern periodic table. Thank you.